So you have learned how to create model classes. Now let's see how we can implement a one-to-one relationship between two models. So here in the models module, let's define a new class called address and assume that every customer should have one and only one address, and each address should belong to one and only one customer. So here we have a one-to-one relationship between customers and addresses, right? Now let's add a couple of fields here, like street, which is going to be a char field with a max length of 255 characters, and city with the same definition. Now, as you probably know, a database relationship has two ends, a parent and a child. The parent should exist before we can store the child, right? Now, I've got a question for you. In this relationship, which class or which entity is the parent? It's the customer, because we say the customer has an address. So the customer should exist before we can create an address. So here in the child class or the child entity, we need to specify the parent. So we add a new field called customer and set it to models.one-to-one field. Now, this field has a couple of required arguments. The first one is the type of the parent model. So here we type customer. Now, the second argument is onDelete, and with this we specify the delete behavior. What should happen when we delete a customer? So if we set onDelete to models.cascade, when we delete a customer, the associated address will also be deleted. This is the cascade behavior. Alternatively, if this field accepts null values, we can use setNull. So when we delete a customer or the parent record, the child record, in this case, the address, is not going to get deleted. It's going to stay in the database, and the customer field or the customer column is going to get set to null. In this case, this field doesn't accept null values, so it doesn't make sense to use setNull. Alternatively, we can use setDefault. So this field will be set to its default value. And one other option we have is protect. And with this, we can prevent the deletion. So if there is a child associated with this parent, we cannot delete that parent. First, we have to delete the child. Now, which value we use really depends on the requirements. There is no one size fits all. In this case, I believe we should use cascade, because if we delete a customer, the associated address should also be deleted. Now, there is one more argument we need to set here, and that is primary key equals true. If we don't set this, Django will create another field here called ID. So every address is going to have an ID, and that means we're going to end up with a one-to-many relationship between customers and addresses, because we can have many addresses with the same customer. But if we make this field the primary key, we can only have one address for each customer, because primary keys don't allow duplicate values, right? So this is how we can implement a one-to-one relationship between two models. Now, you might be wondering if we should define the reverse relationship in the customer class. In other words, do we have to go to the customer class and add a new field called address for the reverse relationship? No, we don't have to do that, because Django automatically creates this for us. So we're done with this lesson. Next, I'm going to show you how to implement a one-to-many relationship. Now let's assume that a customer can have multiple addresses. So we want to change this one-to-one relationship to a one-to-many relationship. How can we do this? Really easy. First, we need to change the type of the field to foreign key. So we're telling Django that customer is a foreign key in this table, okay? Next, we need to remove primary key equals true, because we want to have multiple addresses for the same customer. So we want to allow duplicate values in this column, right? So remove this option. This is how we can define a one-to-many relationship between two models. Really easy. Now it's your turn. I want you to create a one-to-many relationship between these entities. So a collection can have multiple products, a customer can have multiple orders, an order can have multiple items, and a cart can have multiple items as well. So spend a few minutes on this, then come back, see my solution. All right, let's look at my solution. So I've defined a new class called collection with a single field called title. Pretty basic, but note that I have defined this class before the product class so we can reference it over here. So in the product class, we have a new field called collection, which is a foreign key, And this is where we're referencing the collection class defined earlier. Now, sometimes we cannot arrange our code in such a way that the parent class is further up. In those cases, we can pass a string. Just a little tip for you. Now, for the delete behavior, I've used protect. So if we accidentally delete a collection, we don't end up deleting all the products in that collection, okay? What else do we have here? Here in the order class, we have a new field called customer, which is also a foreign key. And for the delete behavior, I'm using protect. So if we accidentally delete a customer, we don't end up deleting orders. In fact, we should never delete orders from our database because all these orders represent our sales. So they should never be deleted, okay? Now, once again, in this case, I had to rearrange my code. So the customer class is defined before the order class, so we can reference it here. Now, we have a new class called order item with 4 fields. We have order, which is a foreign key to order. And once again, we are using protect here. So if you accidentally delete an order, we don't end up deleting the order items. So if an order has at least one item, we will not be able to delete it, okay? Then we have product, which is also a foreign key. And here we're using protect. So if you accidentally delete a product, we don't end up deleting the associated order items. Next, we have quantity, which I've set to positive small integer field. This way we can prevent negative values from getting stored in this field. And we also have unit price, which is a decimal field. Now you might be wondering why I have defined unit price here. Don't we have it in the product class? Yes, we do. But the price of products can change over time. So we should always store the price of a product at the time it was ordered, okay? What else do we have here? We have a new class called cart. We could also call it shopping cart. Here we have a single field, created at, which is a datetime field. And I've set auto now add to true. So this field gets auto-populated when we create a new cart. And finally, we have a new class called cart item with 3 fields. Cart, which is a foreign key to cart. And here I've used cascade. So if we delete the cart, we don't need it anymore. We should delete all the items automatically. Then we have product, which is a foreign key to product. And here I've also used cascade. So if we can delete a product, meaning if that product has never been ordered before, then that product should be removed from all the existing shopping carts as well. That's why I've used cascade here. And finally, we have quantity, which is again a positive small integer field. All right, let's talk about many-to-many relationships. So I'm going to introduce a new class called promotion and define a many-to-many relationship between promotions and products. So a product can have different promotions and a promotion can apply to different products. So let's define a new class called promotion, which is a new model. Now here we're going to have fields like description, which is going to be a char field with a max length of 255 characters. We're also going to have discount, which is going to be a float field. We can also have start date, end date, and so on. Now we can define the relationship in either of these classes. And as I said earlier, Django will automatically create the reverse relationship. Now in this particular case, it makes more sense to define the relationship in the product class because we might have a product that we're showing to the user. And at the same time, we want to show all the promotions that apply to that product. So I'm going to go to the product class. And over here, I'm going to define a new field called promotions. So we use a plural name here because we might have multiple promotions. Now we're going to set this to models.many-to-many field. And just like before, we need to specify the name of the target model, which is promotion. Now with this implementation, Django is going to create the reverse relationship in the promotion class. So in this class, we're going to have a field called product_set that returns all the products that a particular promotion is applied to. Now, if you don't like this name, you can always change it. So in our product class, where we define our many-to-many field, over here, we can supply a keyword argument related name. If we set this to products, Django will use this name as the name of the field in the promotion class. So instead of product set, we're going to have products. Just remember, if you change the default convention in Django it's best to change it consistently everywhere. Otherwise, in some classes, you're going to have a field like products, and in some other classes, you're going to have a field like product underline set. And this makes your code really ugly. So in this implementation, I'm not going to use related name. I'm going to stick to the default convention. Okay, so this is how we define a many-to-many relationship between two models.